Hi everyone, today we will be seeing an important topic called the Kepler's laws of planetary motion in satellite communication. So, Kepler's law, there are three main laws. So, let's begin. So, what is the significance of these laws? So, in what Kepler is trying to say is, see, this is the sun, and these are the planets. These planets are revolving around the sun. So, he is telling like, so the laws governing the motion of these planets around the sun, the same will be applicable to the satellite. Suppose the satellite orbiting the Earth. So the same law of the planets revolving around the sun is applicable to the satellites revolving around the Earth. This is what the basic is. So there are mainly three laws. And the first law is, actually I want to make the concept crystal clear for you, all of you. So I'm going generally through the figures. So by the figure, you will be able to understand the grasp the concept in a better way rather than remembering some statement. So the first law, the first law we can divide it into three parts: A, B, and C. So in the first law, the A part is, see, this is the Earth, and this is a satellite revolving around the Earth. In the first law, the first A, part A, it says this orbit, the satellite orbiting the Earth, that orbit will be ellipse. The shape of the orbit will be an ellipse. That is the first law, statement A. Then we will go to the statement B in the first law. So the first one we told like that path will be an ellipse, and the second one it is coming like, so ellipse, an ellipse is having two focus. We call it as foci, the plural. So two foci, so f1 and f2, and it says like the center of mass of the larger body, and which is suppose there are two bodies here, no, the Earth and the satellite, which is the larger body, the Earth. So the center of mass of the larger body should be at one of the foci. So suppose this is with one of the focus, and the Earth we should be at this focus. That is what, in simply, and the center is also called barycenter. So we have two focus, and at one focus, Earth will be there. Earth center will be at one of the focus. This is the simplest way to explain that. And if we go to the third part of first law, this is it. See, this is an elliptical orbit, and the special case of an elliptical orbit is circular orbit. So you all know, if I'm not wrong, you all know like how an ellipse is, and ellipse will be having a major axis. Major axis is the longest axis connecting from this side to this side, and minor axis is the axis connecting from this side to this side, and both will be intersecting at a point over here. So the major axis and the minor axis, if they are equal, then it will be a circular orbit. It will be a circle. So this is, you don't have to remember all those stuff. You just have to remember like a circular orbit is a special case of elliptical orbit. So I hope the first law is very much clear for all of you. So the first law says like the orbit should be elliptical, and the focal of the two bodies, the larger body should be at the one of the focus. And the third is circular orbit is a special case of elliptical orbit. Okay, then we will go to the second law of Kepler. See, what is the second law? See, we have already discussed in the first law, part 2, that there will be two focus, and one of the focus, the Earth will be there. See, one of the focus Earth is there, or we can say the barycenter. So what happens is like, suppose for 1 hour, let the satellite be here. It is moving like, let us imagine. So it was here from this point, from this particular point to this particular point. For reaching from here to here, it took around 1 hour, let us assume. And the area covered during this time is A1. See, and After some time, the satellite is here. Let's assume the satellite is moving like this, and after some time, it is here. It reaches this point. From this point, it is again reaching this point, and this also took another 1 hour. So during this 1 hour, it set time period. It set an area of A2. So the second law says at the same time interval, that is, what is the time interval here? This is 1 hour, this is also 1 hour. The area set by the satellite in the orbital plane, this is the area set by the satellite during the same time period, the area set by the satellite. Okay, here it is A1, here it is A2. The law says A1 will be equal to A2. I hope it is clear for you. If this is 1 hour, this is 1 hour, then this area A1 will be equal to A2. This is the simplest way of the second law. And we will go to the third law now. As I have already told, this is a third law of Kepler, which is, see, this is an ellipse, and we have, this is the major axis. Let the length of it be 2a, and this is the minor axis. Let the length of it be 2b, and these are the focuses f1 and f2. So the distance from this f1 to f2, let it be 2c. So it says the time period of the satellite in this elliptical orbit. The square of the time period will be directly proportional to the cube of the semi-major axis. What is semi-major? This is major axis. Semi means half of the major axis. That is A, from here to here, or you can take from here to here. So semi-major axis, cube of the semi-major axis, A cube. That is this distance cube, or this distance cube. So the time period of the satellite square will be directly proportional to the cube of the semi-major axis. This is the third law. So these are the main three laws of Kepler, which is very important when considering planetary motion as well as in satellite communication. I hope it is very clear, because I have been using a lot of mainly pictures to illustrate this thing. If you have any doubt, you can ask. So that's it. Thank you.